All right, guys. So I made another video. I made another 3 videos actually explaining why these theorems work. We are on page 55, so I'm not going to spend much time going over why these work. If you want to know why they work, you should be watching the other videos. Okay. Essentially, all you guys need to know is if two chords intersect, that pretty much where they intersect. In this case, E. That if I multiply A times E with E times B, that will equal the product of C, E, and E, D. So essentially just multiply the two parts of the same chord. So again, nothing crazy here. Again, I have two chords, I have A, C, and B, D. So what are we going to say? 4 times 6. 4 times 6 is equal to 3 times X. 3 times X. That's pretty straightforward. 4 times 6 is going to be 24. Okay, and let's go ahead and let's divide by 3. You'll find out that X is equal to 8. So no big deal there. Okay, so 3 times 8 is 24. 4 times 6 is 24. Again, same thing here. We have AB times BC is going to equal DB times BE, right? So again, just make sure you're taking the parts of the same chord. So AB is 5, BC is 12, and that's equal to 10 times X. DB is 10, BE is X, okay? 5 times 12 is going to be 60, and let's divide by 10. I'll find that X is equal to 6. So again, 10 times 6 is 60, 5 times 12 is 60. Okay, just make sure you're answering the question that they're asking. Okay, if they want to know how long is this chord, 10 plus 6 is 16. Notice that that does not necessarily mean that these things are congruent to each other, just essentially that they are going to be proportional. Okay, if we go ahead and let's take this to the next level, again, what do we have? DE times EC, so we have DE times EC is equal to AE times EB. So DE is X minus 4, and we're going to multiply that times X, and that's going to equal 3 times 4. Okay, so let's distribute. X squared minus 4X is equal to 12. Okay, yes, you're going to have to solve a quadratic here. You're going to have to solve a quadratic, so you can complete the square, or you can go ahead and you can factor these. Most of these will be factorable. So X squared minus 4X minus 12 is equal to 0. What are my factors? Again, I know a lot of you guys have been trying to forget this since last year. What are my factors of negative 12 that add up to negative 4? I'm pretty sure that's going to be negative 6 and positive 2. Negative 6 times positive 2 makes negative 12. Negative 6 plus positive 2 is going to make negative 4. So what do we have? X minus 6 times X plus 2 equals 0. Again, little stroll down memory lane. Okay, X minus 6 is equal to 0, and X plus 2 is equal to 0. We're going to subtract 2. X is equal to negative 2, and then we're going to add 6. I'll find out that X is equal to 6. We're going to reject this one. We can't have a negative length. Okay, so again, if you plug that in over here, 6 minus 4 is going to be 2, and this is going to be 6. 2 times 6 is 12, 3 times 4 is 12. If you have forgotten how to do this, that should not discourage you from trying to do the rest of the problems down below. Most of them, as we scroll through this, will not involve that. So don't think just because you didn't know how to do that, you can skip all these parts, because none of these questions down at the bottom will really involve that, except for maybe this last one, number 21. So you're not stopping here. You guys have to get this done. If you want to review this, again, this would be solving quadratics by factoring. Okay. You could have also used completing the square. You could have used quadratic formula. They're generally pretty generous. They don't give you questions that ask you this on the regions, but I will say this, we are going to have to go over completing the square and things like that again because they will come up for some other topics. Okay. Again, here, if we have these two things, 3 times 4 is equal to x times x plus 1. So I have x times x plus 1 is equal to 3 times 4. So what do we have? We have x squared plus x is equal to 12. We're going to set it equal to 0 so we can solve again by factoring. Okay. Again, what are my factors of negative 12 that add up to positive 1? Well, that's going to be 4 and negative 3. 4 times negative 3 multiplies to make negative 12. 4 plus negative 3 adds up to positive 1. So x plus 4, x minus 3. So again, what do we have? X plus 4 is equal to 0. X minus 3 is equal to 0. So x will equal 3, or x will equal negative 4. Can't be negative. So what do we have over here? We have 3 and we have 4. Okay, so they're actually, these in this case actually do bisect each other. They are the same. Okay. Again, don't worry so much about this part right here, the solving quadratics. Like I said, if you want something to review, something to look up, this is what you're going to look up. I will be doing that with my algebra students, so I'll probably have a video on that in the next few days. So, okay, our next one, our secant product theorem. Okay, number one mistake people make. They do the outside times the inside. It's not the outside times the inside. It's the outside times the whole thing. So AE times BE. So the whole thing times the outside is equal to CE times DE. The whole thing times the outside. Okay? So, in the accompanying diagram of circle O, secants CBA and CED intersect at C. AC, this whole thing, is 12. And BC is equal to 3. DC is equal to 9. And they want to know EC. Okay? So again, what are we going to say? We're going to say AC, I'll write up for the first time, times BC, right? The whole thing times the outside is equal to CD, or DC, I'm sorry, they put DC, it doesn't matter. DC times EC, okay? So again, AC is going to be 12, BC is going to be 3, DC is going to be 9, and they want to know how long is EC. Well, 12 times 3 is 36. We're going to divide by 9. And x, which is what we called EC, will be equal to 4. So final answer, EC is equal to 4. Okay? Okay, so they said in the diagram below, PAB and PCD are secants. PA is equal to 4. AB is equal to 5, which means, all right, I know you guys are good at addition. 4 plus 5 is 9. So 5 is not occurring anywhere in your equation. It's going to be 9 times 4. PD, they told you, was 12. Okay? So what are we going to say? PA, they call it PA times PB is equal to PD times PC. Okay? So PA is 4, PB is 9, PD is 12, and PC is X, is what we're trying to find out. Okay? So again, 9 times 4 is 36. And what are we going to find out? X is equal to 3, so PC is equal to 3. Again, I know I switched the order here. I did that just to show you guys that it's multiplication. It's commutative, so it doesn't matter which way you order it. The big thing you guys got to get is the outside times the whole thing is equal to the outside times the whole thing. They love to do this to you guys. I don't know if you guys remember, we had kind of the same situation when we did triangles. Right? We had proportional triangles, right? If you guys remember this, they love to do something like this, like give you this section down here when you had to use the whole thing. It's the same kind of concept. Okay, and the last one, AE. So we have a secant and we have a tangent. Again, the whole thing times the outside is equal to the tangent squared, right? So again, we need, if we're going to multiply the whole thing and the outside, well, what do we do with the other one? Well, you have to multiply something, and since you only have the one thing, you're going to square it, okay? So again, what they give you, they said AB is tangent to circle O, so watch that vocabulary word in there, at B. AC is 16, CD is 9. What's the length of AB? Well, remember, it's going to be the outside times the whole thing. The whole thing, okay? So last I checked, 16 and 9, this whole thing is going to be 25, and that's going to equal AB squared. Well, AC is 16, and the whole thing is 25, is equal to AB squared. 16 times 25 is 400. You can use your calculator for that, but again, think about this. This is 4 times 4 times 25, right? 4 times 4 is 16. 25 times 4 is 100. 100 times 4 is 400. And again, what do we have to do here? This is nice. You take the square root to get rid of the square, and you're going to find out that AB, the square root of 400, is equal to 20. Okay? All right. Over here, they want to know why. So, of course, they're going to make it a little complicated for you. So, what are we going to say? We're going to say DE times DF is equal to DG squared. So, again, what do we got? We have the outside times the whole thing. Well, the outside is 7. And what's the inside? Well, it's Y plus 7. Okay? DG squared is going to be 10 squared. This is going to be 7y, or distribute, plus 49 is equal to 100. We're going to subtract 49. We're going to find out that 7y is equal to 61. And we're going to divide by 7. And we're going to say y is equal to 61 over 7. You can find out whatever the decimal is for that if you'd like, okay? Again, these are going to be the same rules down here. You can kind of do those on your own. What I do expect you guys to do is at least page 60 for today. Today is Monday, and page 61 tomorrow is Tuesday. What I do expect you guys to do is to send me specific questions if you guys have them. Again, they were actually pretty nice. They set these up for you, okay? So in addition to that, so not just set them up, find X. You're probably not going to be able to fit this work on this paper if you've printed it out. If you need to use a separate sheet of paper, please, pretty please, use a separate sheet of paper, okay? So again, what do I expect you guys to do for today, Monday? I expect you guys to do page 60. And for tomorrow, Tuesday, I expect you guys to do page 61. Again, if you have specific questions, please send them, email me, ask me, and I will go over those specific questions tomorrow, okay? I hope you guys are all staying safe out there. Like I said, check out the other videos if you guys want to know why this works. But if not, like I said, your rules are listed on these individual pages, I think from 54 on, and they're all together here. They're all together here on page 59, okay? So like I said, if you guys have any questions, send them over and I will gladly answer them tomorrow. Thank you.